Welcome back to our series video of AIB analog input block. This is our third video. In last video we have checked the analog input signal that integer value is in range or not. For that we have created some alarm. Today first we'll convert that analog input signal to our process value in between that range what we have defined here. For now we have defined, for example, we have defined the range of that analog input signal 0 to 2000 mm. Okay, here I will first write the linear line equation. Okay, y equal to mx plus c. Okay, we can rewrite it as a y equal to y2 minus y1 divided by x2 minus x1. We already told you about that in analog input scaling by using the linear line equation. That video we already published in YouTube. You can watch that video. Okay, here C. Here you can write C as y1 also. How we can show you? Here in paint, if I draw a, okay, now I will draw a line that like this. Okay, for this case, here from this origin point to this intersect point, it is called C. You know that, right? You know that it is called C. This is called C. Okay, but if I also write that this point is as a x1 y1, and the another point here in this line here, if I write it as here, if I write another point here as a x2 minus x1, sorry, x2 y2. So for here to here it's called C. Also you can tell it as a y1. So here we can write it as a y1, C or y1. So we will write it as a y1. Okay, now, and also I will write it here that x2 is our input. For nominal case, x2 is our full range of 648 integer value, and x1 is nominal range as 0. So this is our range, input signal range, nominal case, and x is our random value. In any time it will be changed in between this range. Okay, so is equal to, we can write that 27648, and you know that if I convert this value, this integer value to real, it will be just 648.0. it will be like this. Okay, and here x is our integer value, so we have to convert it real too, because our output is real. So we have to convert all the variable as a real, and then we can make it divided, multiplication or addition. Okay, now here I will write our out value. Our output parameter is called it as a out. Okay, here we will write is out. Okay, and first I will write that slope y2 minus y1 divided by x2 minus x1. Here y2 minus y1 is called as a, y2 is our high value of process and low value of process value. This an input signal range. Okay, so y2 is called the HPV and y1 is called the LPV. Okay, so here I will write first as a HPV minus LPV. Okay, now bracket it and divided by x2 minus x1, and we have convert it as a 27648. It already I have write it as a real 27648 dot 0. So here I will give a bracket. Okay, and here we have x, and x is, you know, it is as a integer. So we have to first I will give a star as a multiplication. So we have to convert that integer value to real. So here we will write int integer to real. This instruction will convert the any integer to real. So here I will write that in okay, this in. Okay, now this input, our input will convert it as a integer. Okay, now here our equation right up to this. Now plus c or y1, so we'll write as a y1, and y1 it called as a LPV, low value, LPV. Okay, now this is our output linear line equation. So if we give the value it as a 500, integer value 500, it will convert in between that 0 to 2000 range, it will show some value. Okay, now I will generate some alarm by using the limit set, high limit set, low limit set, or high limit, low limit. So and that limit we will give from that input like this. So we have to define some input parameter, like here we have write here LPV. So here I have to write HH means high limit range, high limit range, low limit range, low limit range. Okay, so when you create an alarm, you have to reset it to make it normal. So here I will give another input is called the reset. Okay, here I will give another input. I will show why I will give this later. I will show one that is called deadband or hysteresis. Okay, now we found some alarm limit set, and now we will define some tag that for the alarm keep the memory the generate alarm will store. Okay, and that alarm I have to make it in output. Okay, here I will make it as a out. Okay, and that high is alarm, high as a warning, low as on, low as a alarm. Okay, and that all are boolean tag, that all are boolean tag. Okay, one thing I have to first clear, I want to clear you that I already told in another video that when we have made FC and FB function for call block, that output should not use as a output that variable, we should not use it as a input variable. For FB you can use, it will give a result, but when you compile, it will make a warning. But if you use the output as input in FC, your function will not work for that variable. So for intermediate use, we will create some other variable. Okay, here I will create in static that high alarm temporary. Okay, low high alarm high on temporary. Okay, low on temporary and low on temporary. Okay, and also I don't want to use that. This is also the output parameter, so we don't want to use that output parameter as an input. So here I will create another variable, name it as a out temporary temp, and this is the real. Okay, this is real. So we will create that output as a temporary, and here I will copy that output from the out temp. So here you see that this we can use as a input here for this out, but if we use that out as input of another logic, then it will give a warning. For FB it will work, you will not get any error, but it will give a warning. Now here we will create alarm. Okay, so high, give a quotation that is limit check. Okay, is limit check. Okay, so we will use a if instruction to check the limit. So if the output value, this out temporary, we cannot write here that out, it will means it is a input of that logic, so we will use that out temporary. So if the out temporary greater than ace, if we set ace as a 1500, so if the out temporary value more than 1500 mm, our alarm will generate. So here I will write it as a then if the out temporary value greater than ace, then our ace on temporary will set as a true. Okay, set as a true. Else if else if out temporary, okay, greater than or equal, you can give us a greater than or equal, out temporary is less than ace, then ace warning, this warning will be false. Okay, and if now our alarm is generated. Okay, now think that if the value out value is just equal or more than 1500, our alarm will generate. Okay, here I will write. Okay, here if I write it as a for 1800 for on alarm generation, for warning 1500, and low for 500, and low for 300. Okay, hysteresis suppose 50 mm. Okay, why we have to use 50 hysteresis, I will tell you. Okay, now suppose if the out value is equal or greater than 1500, our high warning will set as a true. And again, when it is less than ace, it can be 1500 1499, so it will be false. So once it is 1500 it will set, once it is 1499 it will be reset, and this will be unstable your operation. It is not good. We have to make or set a red band that alarm will generate when equal to 1500 and should reset when the value is less than 1450, because we have set it here as a hysteresis 50. So alarm will set when value is less than 1500, and that will done by subtract hysteresis. Okay, so this will generate when equal or greater than ace and reset when less than ace minus hysteresis. And same way we will generate the low alarm for L alarm. Okay, here I will give ace, and this is not greater than, out temperature is less than or equal. Here we have to write less than or equal. When our value is less than or equal to our limit set L, then our low one will true, else if out temporary is not less than, is greater than L plus hysteresis, then our low warning temporary will reset. Okay, so we have created the alarm, so it is not set. When it will less than L, low limit, it will set. When it greater than low limit up to hysteresis, it will reset. And maybe it will reset without acknowledge. So we want to make this alarm as holding up, without acknowledge it should not reset. So here we will create the alarm that we have set as here output parameter, this one ace or L. Ace on will, okay, this one will set when ace 1, sorry, ace on temporary is set. Okay, or ace on will set when this value is true, sorry, this value is, this signal is true, and when it's true maybe it will be false, so we have to hold it, and we will hold by this one. Okay, so here we'll write ace on. Okay, and it will not reset until and it is on, it will not reset until you give the reset command. Okay, rst reset. Okay, see, it is showing as operator and is not compatible with the data types of bool warning. Okay, here out bool, and that all are and this is reset is our Okay, here reset is boolean tag, that's why it is create the warning alarm that now it is true. So each warning will create. Now for L warning I will write as L on. Here I just write change the L. Okay, this alarm will generate when the value is cross the limit. But if you want to make it delay, that if the value is cross the limit, we want to make it delay up to 2 seconds or 3 seconds. So we have to give another logic here. Okay, here, so we need a timer. So here I will write as a T on 1, timer 1, T on 1. Okay, sorry, T on timer, and we need a time, and time you can set from the input variable. Time you can set from the input variable. So here you need to define in input parameter that time. Okay, and time here td, time delay. Okay, and data type is time. Okay, here I will write the timer that t on 1. Okay, give a comma in, and our input is high on temporary or low on temporary. In both case we want to generate the alarm. So here we'll write this one or this one, any alarm. This is for warning. We'll use same timer for both warning alarm. Okay, now give a comma pt. We don't want use to et, we'll use just pt. Okay, here pt is preset time, and our preset time that we want to make it delay, that td. Okay, so this is all. We don't want to use the output and the et, timer elapsed time. Okay, here I will make the we'll call that t on timer here. Okay, here this warning alarm will generate. Forget this up to this one thing here, that this warning will generate when this on is on will high, and this t on timer output is high, t on 1. Okay, dot q, q is high. Okay, give a bracket. Okay, so this on alarm will generate when is warning temporary or t on is high. Okay, when this t on is high, this 2 is high, this will high, and this high we have used here as a OR gate. Okay, so it will be true hold. If this one of this is false, it will hold, not get, because our reset will not always true, it will always false. Okay, now we'll use here that and t on 1 dot q. Okay, give comma give bracket, and here we have to use not. Okay, this is the alarm we have generated for high limit and low limit. Next video will generate high and low as well as we'll copy the low range high range to our output parameter here. This block is now red because inside parameter is changed. If you update by clicking this one, it will be okay, or you can go just right click on that block. You can click update block call, so it will true. Okay, save, and we'll next video will copy the other alarm and make simulation. Okay.